you can create Microsoft keys or built-in keys that Microsoft will provide you access to. Ultimately, they are generated by Microsoft, but they don't have access to the keys. If that doesn't appease some of your security and accreditation auditors, then you can generate and import existing keys if you've generated them somewhere else and you want to import them. Most of the Azure tooling now supports that. I think there may be some stuff around NetApp files that is on the roadmap for support, but yeah, the use of HSM, so hardware security modules, will allow for you to import some keys that you trust the generation of that has been performed in a trusted manner, and call upon that as well. It's FIPS compliant, so to a very high level, the FIPS 140 level 2. Obviously, it's an American standard that's supported by NIST, which is the Institutes of Standard and Technology in America, but that has been widely adopted by the UK government, and yeah, the NIST framework is very well aligned to Cheltenham and certain other government agencies as well. So providing access to your data, this is very much in line with Key Vault. So Key Vault plays a big part of this as well, especially with some of the shared access and shared key generation. But making sure that where we store data and on storage accounts and within Azure, it's protected to a certain level, is obviously key, because we're all custodians of data. We need to ensure that we have the right mechanisms in place to make sure we adequately protect the data that our organization holds. Access to underlying storage accounts is requested via HTTP and HTTPS, hopefully not the unsecured version. Hopefully everyone's put HTTPS in everywhere, but there may be legacy applications or certain exceptions that may require the unsecured version, but understanding that and mitigating that is key to having a mature security model around access. On the left, we've got the different types of authorization we can enforce on data and storage resources within Azure. AD speaks for itself in both the Azure AD and on-premise, more traditional AD. You can delegate access to Active Directory groups within the RBAC mechanisms. If you have an existing on-premise mature NTFS model where you might be using data access control lists, you can add modules to Active Directory such as domain services, ADDS, to enforce NTFS permissions from an on-premise controlled estate and source of identity management as well. So the access to this can work in a pure cloud or on-premise or hybrid of the two as well. Shared keys. So these keys are generated to authorize access to certain declared resources. There are two headers in the string that's generated for this key. The first is a UTC timestamp. So that date is very important to understand the generation of the key to when it was created, because shared keys traditionally use timeouts as a security mechanism, so that they won't trust a key that's older than, say, 15 minutes or 2 hours or whatever policies you enforce within your organization. So having that UTC timestamp is very important for authorization processing. And then there's the authorization header, which contains details of what access to the resources that you're allowing for that key as well. Shared signatures is a URI that grants access to restricted Azure storage resources. So it's very much at a lower level. It's not kind of declared all resources. It's that it has to be an Azure storage resource. It's used to provide access to clients who may or may not be trusted with storage account keys or shared keys, where you're kind of giving them that trusted access. So the shared signature will grant access for a set amount of time to a specific set of resources. There's 3 levels of account keys. Shared access signature keys. I'll get my teeth stuck in. One of them's a service level, the other one's a user delegated key, and the other one's an account level. So depending on how you're trying to protect your resources, which services are trying to access the services will also allow you to build that filtered, layered approach to how you manage storage on Azure. The last one there, you're probably all wincing at why is that even on there, but it's worth pointing out that anonymous public read access is an option for resources here. So if it's been configured by mistake, or it's there because there's a certain application that doesn't support access in one of the other models, God forbid you're using it, but there's people may have systems out there. It's worth pointing out that obviously this isn't supported by anyone, Microsoft, by Cloud Direct, by anyone, but it does exist. So it's worth calling out that it's probably an item that you want to monitor for, and make sure public read access, anonymous public read access is flagged if any resource has been configured with this as well. So just a bit of warning there. Moving on to controlling networks. So network access control is just as important within Azure as it is on premise. The principles of least privilege access applies everywhere, regardless if that's on premise or it's in the cloud. The same way of working will allow you to enforce network access on network access controls in Azure by taking advantage of aspects such as network security groups, firewalling. We'll go into them in the next couple of slides, but ultimately controlling access to resources at the network layer is a significant level of protection for your resources. Other mechanisms will involve techniques that have been around for as long as I've been in IT. So before the advent of cloud, so things like network segregation, subnetting, defense in depth, routing, tunneling. Many of these standards have existed before Azure existed, and they're still best practices and should still be looked at to be deployed onto the Azure toolset. That is still a valid approach for deployment on Azure. Azure make it very easy to deploy some of this as well, so utilizing infrastructure as code, utilizing ARM templates, Terraform templates to enforce network segregation through subnetting and forced tunneling. There's also Azure blueprints, the way we can deploy hub and spoke architectures and enforce network peering to sensitive areas and make sure we control routing to all aspects of our estates as well. Microsoft don't force you to use their tooling at all times as well. So virtual network appliances, both Microsoft and third parties are available. So we'll talk about firewall in a minute. But a lot of customers also utilize trusted devices that they've used on premise, or they have certain features that aren't available in the Microsoft toolset as well. Things like Palo Altos, Barracudas, you name it. The devices are out there, and they can be used in conjunction with the tooling, the networking tooling within Azure. VNets and subnets, and all the monitoring is embedded in that as well. So you're collecting the alerts. It just allows for that rich marketplace of SMEs to provide value back to the Azure